this first one, okay, is find the partial fraction decomposition. So the first thing you want to do is look at your denominator, God bless you, and factor it. So the factors of -8 that sum to -2 would be -4 and +2. And then you've got two factors there. They're not repeated, so this is hopefully on the easier side, right? There's two factors, so each one gets a fraction. And I start there. So then the next step is to multiply the numerators of each of these fractions by what the denominators are missing when you compare this to this. So that x plus 4, one is missing the x plus 2, and the x plus 2, one is missing the x minus 4. And then the step we're skipping is multiplying the top and the bottom, okay? But we would have done that making all the denominators the same, which means you can focus on just your numerators. So if I rewrite that, that's 3x minus 1 equals a times x plus 2 plus b times x minus 4. And then one at a time, I want to cancel out one of these variables. So I would start by saying x equals -2 because that would cancel out the a. And then x equals +4 because that cancels out the b. And then I plug it into every x that's in that row. So 3 times -2 minus 1 equals a times -2 plus 2 plus b times -2 minus 4. And I get -6 minus 1 equals a times, this is my 0, so it's going to actually cancel out the a. B times -6. And then I get -7 equals b times -6. And b would equal -7 over -6, so positive 7/6. With me so far? Then I repeat that whole process for b. So x being 4. 3 times 4 minus 1 equals a times 4 plus 2 plus b times 4 minus 4. I get 12 minus 1 equals a times 6. And then this is again my 0 canceling out the b. 11 equals a times 6. And a equals 11 over 6. And then I need to take those and put them in to the equation that I had set up with the two variables, or expression, sorry. So a is 11 over 6 goes over x minus 4. Plus b, 7 over 6 goes over x plus 2. I can't leave a fraction within a fraction, so the denominators go down to the bottom. I'd get 11 over 6 times x minus 4 plus 7 over 6 times x plus 2. And then they both have 6 in the denominator, so I can actually factor out 1/6. If it's the same, so like in the example we did yesterday, there was a 4 and a 2. If it's not the same, I'll let you leave it. But if it's something like this, where it's exactly the same number on both, where it has the same the common denominator, then yeah, I want you to pull that out.
So if we don't distribute the 6?
No. No, you're actually trying to simplify it, so you're going to factor it out. Okay, it's not on the warm-up, but there was another case yesterday that we talked about what happens if there's 3 denominators, right? So let's say the denominator had x plus 3, x, once you like factored it out, and then x, let's say that, right? So it would have been a over x plus 3 plus b over x minus 2 plus c over x. Okay, we worked through an example in which you one at a time had to cancel these out, right? So, which is obviously still the way you want to do it. But if that confuses you, if you're like, I don't know what to plug in because it might cancel 2 of them out, then if you want to know what to plug in, you can simply just solve this. So I would know at one point I have to plug in a -3, at one point I have to plug in a 2, and at one point I have to plug in a 0. If you do that one at a time, you will eventually see them cancel out. It may not always be in the order that you expect. You won't always cancel A first, then B, then C, but it doesn't matter. If you plug those 3 values in separately of each other, obviously, then you'll end up canceling out and getting each of those 3 numerators. All right, then you've got these, right? So in appearance from the beginning, it doesn't look like it's a repeated factor, but if you factor x squared minus 2x plus 1, what is that? X minus 1 squared. Repeated factor, right? It would be x minus 1 times x minus 1. When you have a repeated factor, you've got to build up to it. So this would be equals a over x plus b over x minus 1 plus c over x minus 1 squared. Then I want to go through and multiply out what's missing. So from the x to this x times x minus 1 squared, I'm missing both of the x minus 1s. So I'm missing x minus 1 squared.
I understand why you have to build up. How can you put x minus 1 twice if you put it squared like that?
You have to build it up. So if you want to test it out, if you just do x minus 1 squared, you actually don't end up getting the right, and work backwards to check it. You don't end up getting the right answer. Yeah. You could just take my word for it, or you could work it all the way out to prove it, but it won't work, like if you just do x minus 1 squared. All right, so then b is missing an x and another x minus 1, and c is missing the x. So then I get the numerators 2x squared plus 3x minus 1 equals a times x minus 1 squared plus b times x minus 1 plus, God bless you, plus c times x. And we talked about that with a repeated factor, you can't do it the way that we did it, right? If we had solved, if this is x minus 1 and x minus 1, and we solved that, we'd get 0, 1, and 1. And you can't plug the same number in twice because it will cancel out the same things. You'd never be able to get all three. So this is where you've got to distribute everything on the right-hand side and then group them. So I know x minus 1 squared is x minus 1 times x minus 1. It's also already up here. So that's a times x squared minus 2x plus 1 plus bx squared minus bx plus cx. So ax squared minus 2ax plus a plus bx squared minus bx plus cx equals 2x squared plus 3x minus 1. Now I'm going to group together all the x squared terms. So I'd get 2x squared equals ax squared plus bx squared. Then I'm going to group together all the x terms, and I get 3x equals negative 2ax minus bx plus cx. And then I'm going to group together all the ones without an x, which is just negative 1 equals I. Still with me? So from everything in the first one, I can actually cancel out the x squareds, and I get 2 equals a plus b. From the second one, I can cancel out all the x's, and I get 3 equals negative 2a minus b plus c. And the last one already gives me what a is. I'm going to take that, plug it into the one that only has 2 variables. 2 equals negative 1 plus b, and b is 3. And then b and a both go into that middle one. 3 equals negative 2 times negative 1 minus 3 plus c. And I get 3 equals 2 minus 3 plus c. 3 equals negative 1 plus c. And c equals 4. Good? Yeah. And then you want to plug them back in. So my answer is this with the a, the b, and the c substituted back in. So negative 1 over x plus 3 over x minus 1 plus 4 over x minus 1 squared. With extra time, you can work those out, put it all together, and you should get your question. All right, so 7-1 to 7-3 quiz is Monday. You can use scientific calculators. You won't need to have that, so this is like one of those days where I really don't feel bad if you don't bring it, because it's your own fault, and I'm telling you, you could bring it to help you. But if you don't bring it, I won't be lending you a scientific calculator, because you can do all this stuff without it. It's just when it comes to, if you think about those word problems and you're dividing like decimals and all that stuff, it certainly will be helpful. So 7-1 was the substitution and elimination. We had the break-even word problems in 7-1. You had revenue, so that's the revenue equals cost is your break-even. There's something else. Oh, and you had the percent interest. So if you invest money in a certain percent interest and invest money in a certain percent interest and find out how much, that was in 7-1. And then 7-2, we had elimination. And some additional word problems here, like what's the optimal amount to sell for supply demand. And then we had word problems dealing with, like rectangles or whatever it is. There's going to be some sort of word problems with systems between those two sections. And then 7-3 was when we started doing 3 variables. These are the triangle ones and the systems where you have to number them, group 2 together, get the new equations, and then solve from there. And then you also have the partial fractions. So there's a quiz review with the solutions on it on the quiz assignment itself. It's non-graded because I'm giving you all of the answers, okay? But if you really want to be prepared for this quiz, you better work through that, okay? Do whatever you need to do to make sure you're successful. Questions for me on the quiz? Okay.